Good morning friends, myself Dr. Chandrakant Shivaji here. So in this video we consider the Savitribai Phule Pune University launched this FY/BSc CBCS pattern on 2019. So in semester first, chemistry theory paper first, that is CH-10 physical chemistry, for 2 credits, 50 marks. These 50 marks are divided into 15 for internal assessment and 35 for external assessment. Theory paper for CH-10 physical chemistry, we have 3 chapters. This consists of the 3 chapters: chemical energetics, chemical equilibria, ionic equilibria. So in chemical energetics, we consider this reviews of thermodynamics, the laws of thermodynamics, important principle and definition of thermodynamics, concept of standard state, standard enthalpies of formation, integral and differential enthalpies of solution and dilution, calculation of bond energy, bond dissociation energy, and resonance energy from thermochemicals data, variation of enthalpy of reaction with temperature, that is Kirchhoff equation, statement of third law of thermodynamics, and calculation of absolute entropies of substance, and the problem based on various concepts. In second chapter, that is the chemical equilibria, we have to consider this introductory part, free energy and equilibrium concept, definition and significance, the reaction gives energy, exergonic and endogonic reactions, the perfect gas equilibrium, general case of equilibrium, the relation between equilibrium constant, molecular interpretation of equilibrium constant, the response of equilibria to conditions, response to pressure, response to temperature, one of equations, values of K at different temperatures, and problem with different concept. Last chapter, third chapter, is a ionic equilibria. So in this chapter we consider strong, moderate and weak electrolytes, difference between these three properties, degree of ionization, factors affecting the degree of ionization, ionization constant, ionic product of water, ionization of weak acid and bases, pH scale, common ion effect, salt hydrolysis calculation of hydrolysis constant, degree of hydrolysis and pH for different salts, buffer solution, solubility and solubility product of sparingly soluble salts, application of solubility products principle. So these are the 3 chapters we have to cover in this theory paper for CH-10 physical chemistry. Let's move to first chapter, chemical energetics. So these are the content we have to cover. Consider the first concept, that is thermodynamics. Thermodynamics is a branch of science which deals with conversion of heat into mechanical work and vice versa. Thermo means heat, dynamic means motion or mechanical work. Study of thermodynamics is based on their 3 different laws: first law, second law and third law of thermodynamics. Objectives of thermodynamics: to predict the feasibility of process, whether a given process will occur or not under a given set of conditions, it is predicted by using thermodynamics. In second objectives, it to estimate the yield of product. So when we consider process or chemical reaction, so this conversion of reactant into product, what are the conversion ratio or yield of product form during this reaction or process can be predicted by using the thermodynamics relation. And the third is to deduce some important relationship. So this thermodynamics gives the important and useful results such as Raoult's law, lowering of vapor pressure, depression in freezing point, elevation in boiling point, distribution law, phase rule, from the study of this thermodynamics. So when we consider the objectives of thermodynamics, this thermodynamics have some limitations also. So what are the limitations? So consider these 3 limitations. All properties like temperature, pressure of matter in bulk form, in bulk or microscopic quantities, not in microscopic quantities. So in this case, when we consider this temperature, pressure, at that time we consider the large number of molecules, atoms gathered together. It is not predicted the properties at molecular or atomic level. Second is it deals with the feasibility of process, but it does not give idea about the time taken for completion of process or rate of process, whether a given reaction complete in given time or what is the rate of reaction. This is not given by the thermodynamics. And the last is third is it does not reveal the mechanism of the process. Its treatment is limited to initial and final state of system. So in thermodynamics, this reactant is converted into product, but in between this, what are the intermediate? That is not considered in thermodynamics. Next point is the Zeroth Law of Thermodynamics. Whenever two bodies have equality of temperature with the third body, then these two bodies have equality of temperature with each other. So when this first body, second body is equality of temperature with the third body, at that time these two body mutually undergo the exchange of temperature with each other. So this is the zeroth law of thermodynamics. So this is the common sense, it do not require any explanation. So on the basis of this zeroth law of thermodynamics, we have first law and second law of thermodynamics. First law of thermodynamics. So what is the statement of first law of thermodynamics? There are various statements. Energy can neither be created nor be destroyed. It can be converted from one form to the another. Second is the total energy of isolated system remains constant. If certain quantity of some form of energy disappear, then same equivalent amount of some other form of energy must be produced. Last is a fourth, it is impossible to construct a machine which produce work continuously without consumption of energy. So these are the four statements of first law of thermodynamics. This Einstein in 1905 showed that energy produced by the destruction of mass m is given by its famous relation E is equal to mc square. Einstein famous equation. So this whenever the energy is created, mass is lost. So on the basis of this Einstein equation, this first law of thermodynamics is modified, and this law of conservation of energy has modified as the total mass and energy of an isolated system remains constant. What are the mathematical formulation? Delta U is equal to Q plus W, where Q is the heat supplied to the system, delta U is the increase in internal energy of the system, and W is the work done by the system. This equation is further write as delta U is equal to Q minus P delta V, or Q is equal to delta U plus P delta V. What is this P delta V? Where this P delta V is the work done in the form of expansion. Second law of thermodynamics statement: all spontaneous processes are thermodynamically irreversible process. For example, the heat flows from hot to cold end, flow of water down a hill, etc. The complete conversion of heat into work is impossible without leaving some effect elsewhere. Without the use of any external agency, heat cannot be itself pass from a colder to the hotter body. It is impossible to construct a machine functioning in a cycle for convert heat completely into equivalent amount of work without producing changes elsewhere.